Good evening. Today the episode will be solving Wyatt type questions on indices. But you can see the first question here. Simplify the expression to its a Wyatt type question on indices. I space for x times 25 raised to power x minus 1 over 125 raised to power x plus 1. So now before we can simplify, you can see they have different bases. The first thing to do is to make them have the same basis. How can we do that? You can express 25 and 125 in terms of 5. So let's do that first. So we have 5 raised to power x times 25 equals 5 square. Yes, so we can write it as 5 square raised to power x minus 1. Then over 125 is 5 raised to power 3. You can write this as 5 raised to power 3 raised to power x plus 1. That's the first step. If you want to simplify, make sure they all have the same basis, as you can see here. Then we can simplify further by saying 5 raised to power x times 5 raised to power. Then we apply one of these laws, 2 times x, 2x, then 2 times minus 1 as minus 2 over, use the same to the denominator, 3 times x, 3x, then 3 times 1 as plus 3. Then the numerator, you can apply the first law of indices. You can see they have the same basis, 5 and 5. So then you can add the indices. Then that's 5 raised to power x plus 2x minus 2 over 5 raised to power 3x plus 3. Then you can add 5 raised to power x plus 2x is 3x minus 2 over 5 raised to power 3x plus 3. Also, you can see that we are dividing by two numbers here in the index form, and they have the same basis. So you can apply the second law, where if we have two numbers in the index form and then they have the same basis, what do? We simply subtract the indices. We subtract the indices. 5 raised to power 3x minus 2, then minus. So now minus the indices of the denominator as 3x plus 3. So as simple as that. Since they have the same basis, you can now minus the indices. Then 5 raised to power 3x minus 2. Or you can see minus 3x. Then this minus will avoid the 3 because minus 3. Affect the two numbers there. Affect the 3x and then the 3 minus 3x minus 3. And now equals 5 is to power. Correct like times we have 3x minus 3x minus 2 minus 3. And that equals 5 raised to power. 3x minus 3x becomes 0. Minus 2 minus 3 becomes minus 5. And that is 5 is to power minus 5. Can simplify by removing the negative sign. How do you eliminate negative sign? You simply turn it to 1 over 5 raised to power 5. Then remove negative sign. And that's all. So with this, we've simplified the expression. Let's see another typical YX type question on indices. This time around, what we want to simplify? Simplify 6 is power 2n plus 1 times 9 is power n times 4 is power 2n all over 18 is power n times 2 is power n times 12 is power 2n. Let's simplify this. We said earlier that before we can simplify, you have to see that you have the same basis. They have similar basis before we can simplify. Now you can see none of these numbers have the same basis. But then you can see that 2 and 4 are different bases, but then we can make them the same. How? Let's express 4 in terms of 2 because 4 is 2 square. That's 1. Then 2, you can see that as for 9, you can also express 9 in terms of what? In terms of 3, right? Then also you can express 6 in terms of 2 and 3 because 2 times 3 is 6. This is what we are seeing. As for 6, we have 2 times 3 is to power 2n plus 1. The 6 here is this 2 times 3 you are seeing in easy brackets, right? Then times, as for 9, 9 is 3 square. We have 3 square, then is for n, then times 4 also is 2 square. So 2 square is to power n. We have this n for the denominator. For 18, We can write 18 in terms of what? In terms of 2 and what? And 3. 18 normally is 9 times 2, right? But 9 is now 3 squared times 2. You can see you said here that 9 equals 3 squared. So 18 is 9 times 2. But then 9 is now 3 squared. 9 is 3 squared, then 2. How is the 18 you can write as 3 squared times 2 all raised to power n times 2 raised to power n, then times 4 2 also. It can be written as 4 times a. But then the 4 also can be written in terms of 2. Said 4 is 2 squared. 2 squared times 3. 2 squared times 3. 2 squared times 3 raised to power 2a. We can simplify for that. He said earlier that anytime you want to simplify, what you have to do is what? Make sure they have the same basis. And you can see now, we now have 2 and 3, 2 and 3. Let's see what next. Then we can now simplify this and say we have 2 raised to power 2n times 3 raised to power 2n plus 1. Then times 3 raised to power 2 times n, 2n times 2 raised to power 2 times n, 2 raised to power 2n, then over. Then how did 2 times 3 all raised to power 2n plus 1 became 2 raised to power 2n plus 1 times 3 raised to power n plus 1? It's simply from our law where we said that if we have a times b all raised to power n is equal to what? A raised to power n times b raised to power n. We should just split the two numbers and then give each of them the power. They both share the power. So how would you have done here? We repeated the 2 and the 3 and then give each of them the power outside. Yes, that's the use of there. Also make use of below here also where we have 3 raised to power 2 raised to power n, then times 2 raised to power n. You can see both 3 and 2, both 3 square and 2. That power is outside. Then now we give each of them the power. 3 raised to power 2 raised to power n, then 2 raised to power n. Then times 2 raised to power n. We apply the same law here also. 2 raised to power 2, then the 2n is outside, then times 3 raised to power 2 n. Can simplify further, right? Now we can also that we have like terms. Okay, let's simplify the denominator first. This is 2 raised to power 2n plus 1 times 3 raised to power 2n plus 1 times 3 raised to power 2n times 2 raised to power 2n, and all over 2 times n is 2n. We have 3 raised to power 2n times 2 raised to power n times 2 raised to power n, then times 2 raised to power 2 times 2n is 4n, then times 3 raised to power 2n. Yes, so we have this. So let's collect like terms. We can see what are like terms. They are the ones that have the same basis, because they are the ones we can simplify. If they don't have the same basis, then you can't simplify them. Or you can simplify them, they have to have the same basis. So let's collect like terms. 2 raised to power 2n plus 1 times 2 raised to power 2n times 3 raised to power 2n plus 1 times 3 raised to power 2n. As if we already like terms. Base 2, base 2, base 3, base 3. So also a raised to power 2n times 3 raised to power 2n. Then times 2 raised to power n times 2 raised to power n times 3 raised to power 4n. You can see. Now we apply. Let's try to simplify the numerator separately and the numerator separately. For the numerator now, those two numbers that have 2 as their base, this and this. What do we do? Apply the first of indices. Since they have the same basis, which is 2 and 2, what do we do? Simply add their indices. 2n plus 1 plus 2n. Also their indices, 2n plus 1 and 2n. So 2 is power 2n plus 1 plus 2n. Then times, for this is also 3 and 3. They have the same basis also, and that's 3. What do we do? Is add their indices. 2n plus 1 plus 2n. And for the denominator also, we check this ones that have 3 and 3 as their numerator, as their basis rather. That's 3 is power 2n plus 2n. Since they have the same basis, we can add their indices. And for 2 also, that will be 2 is power n plus 4n. The 2 here has the power of n, power of n, the power of 4n, adding all the powers together. And this is now equal to 2 is the power, collect like times 2n plus n plus 1, right? Times First like times 2n and 2n are like terms. Times 3 raised to power 2n plus 2n plus 1. Then over 3 raised to power, cannot simplify here. 2n plus 2n is 4n. Then times, you can simplify here also. 2 raised to power n plus n, 2n. N plus n, 2n plus 4n, 6n. So we have 6n here. As equals, can now simplify here at the numerator also. 2 raised to power 2n plus 2n is 4n. 4n plus 1 times 3 raised to power 2n plus 3 is 4n plus 1. 4n plus 1. We will now have 3 is power 4n times 2 is power 6n. You can see the first step was to what? First step was to make sure they all have the same basis. And you can see I splitted them. One that was 9, we made it equal to 3 squared. One that was 4, made it equal to 2 squared. One that was 6, made it 2 times 3, it splitted it. One that was 18, made it 9 times 2, we that turned 9 to 3. You can see they're now becoming, they become to have the same basis. They begin to have the same basis. 2, 3, as you can see. So that is the trick behind it. We will now simplify it now. We applied the first and second law of indices. Now you will notice here that here is a base of 2 here, a base of 2 here, base of 3 here, base of 3 here, which tells us that we can still apply second law of indices because we are dividing now. So simplify those ones, right? What we now have is 2 is to the power 4n plus 1 times 3 is to the power 4n plus 1. According like terms. We will have 2 is to the power 6n times 3 is to the power 4n. Since we are dividing these two, 2 is to the power 4n divided by 3 is to the power 6n. The final second law of indices, we would have 2 is to the power. The same basis 2 and 2. So 4n plus 1 minus 6n. Then times, I'm going to divide in 3 is to the power 4n plus 1 over 3 is to the power 4n. They have the same basis and we are dividing, right? What do? We subtract the indices. 3 is to the power 4n plus 1 minus 4n. That's equals 3 is to the power 4n like times 4n minus 6n alike terms, then plus 1 times 3 is to the power 4n minus 4n alike terms, then plus 1. That's equals 3 is to the power 4n minus 6n is minus 2n. Minus 2n plus 1. Then times 3 is to the power 4n minus 4n is now 0 plus 1, 1. And then we now have finally 3 is to the power minus 2n plus 1 times 2. And that's our final answer. So while you can't simplify for that because 2 and 3 are different bases. If they are the same basis, then we can apply the first of indices. But then they have the same basis, then that'll be our final answer. We are under our extra question. And then this is to simplify. So simplify 343 is for minus 1 over 3 times 0.14, this for minus 1 times 5 is for minus 1 over 3. We can see that all these numbers have negative indices, negative powers. And at the same time, we are simplifying numbers with negative indices. The first step is to try to remove those negative signs so as to use our calculation. That's the first step. Try to remove those signs. Let's start with that. Now, so what happens here? This becomes 1 over 343 is to the power 1 over 3. If you remove negative sign, let's have 1 over, then the whole number, the index. Except that you remove the negative sign. That's why you are saying 1 over. Then, as for here, times, before there is negative sign in the second number here, let's try to convert the number to a fraction first. Anytime you have a number in decimal, try to put the fraction. If I work with indices, put it in fraction. This is how we 14 over 100, right? Is to the power minus 1 over 1. Even n is still there, you can still see minus 1 there. Yes, put the fraction first. Then minus. As for this now, to move negative sign, what happens? We have 1 over 25 is to the power 1 over 2. If we move negative sign, we proceed. We have 1 over 343 is to the power 1 over 2 times. Now, we move negative sign. Now, what do we do? So we also do 1 divided by 14 over 100 times 1 over 25 is to the power 1 over 2. But I said anytime you are anytime you have 1 divided by a fraction, don't bother to start dividing, right? Just invert the fraction. Anytime you have 1 divided by the fraction, just invert the fraction. Take the 1 at the bottom up, run up to the bottom, right? So here, this becomes 1 over cube root of 343. Instead, the numerator of the fractional power becomes what? Root. And you can see that 3 is the numerator, so it becomes root, cube root. Then times 100 over 14. Just invert the fraction. Then times 1 over, so it becomes what? Square root of 25, as you can see. And this equals 1 over square root of 3 is 7. When you multiply 7 by itself 3 times, you have 3 por 3. So a cube root of 3 is 7. Then times 100 over 14. And times 1 over 25. It is square root of what? 1 over 5 further. That's square root of 25. Then 5 in 100 is 20. And then now 10 times 120 over, the numerator is now 14 times 7. I have 98. Then 3 in 20 is 10. 3 in 98. 3 in 9 is 4 in the 1. 3 in 18 is now 9. We have 10 over 9. We have 10 over 9. You can use to turn into mixed fraction. That will be 9 in 10. 1, right? With the 1. Then add 0 to this. 9 in 10 is now 9, right? So 9 in 10 is 1. With the 1, right? And over 10. Then that's the answer in mixed fraction. Another YX type question on this is simplify 25 is per minus 1 over 2 times 27 is per 1 over 3. Then plus, very careful, you can see plus at the center there. 1 to 1 is per minus 1 over 2. Then times 6 to is per minus 1 over 2. Now before we proceed, let's try to recall board mass. So in board mass here, so we use board mass when we have a series of operations. We have plus, divide, times, so to know which one you actually deal with first. So you can now see multiplication here, which is M, and also addition, which is what? A. So you can see in board mass, M comes before A. That means we have to do it on location, so first before the addition. That is, we have to actually multiply these two separately, this separately, then we now add. Yes. Yes, I will do that. So 25 this time I run over 2. Know the negative sign, it becomes 1 over 25 to power 1 over 2. Then times 27 is to power 1 over 2. There's not any negative sign, which means that way. Then plus 1 over 1, 2 1 is by 1 over 2. No negative sign, then times 1 over 6 to 5 is to power 1 over 2. Then those fractional power now becomes root 1 over root 25 times cube root of 27 plus 1 over root 121 times 1 over square root of 25. This is now equals 1 over square root of 25 is 5 times cube root of 27 is 3 plus 1 over root 121 is 11 plus 11 times 11 is 91. Then times root 165 is, sorry, root 625 is 25 over 25. And we said you have to multiply first before we add. So 1 over 5 times 3. 3 times 1, 3 over 5. So we have 3 over 5. Then plus 1 times 11. 1 times 1, 1 over 11 times 25. Count the LCM of 5, 11, and 25. So you can write by 5. So write in 5, 1, write in 11, 11. Then we have 5 also. And write by 5 also. 1, 11, 11. And 5 also is 1. By now is 11 also. 11, 1, 1, 1. So the LCM is actually 5 times 11 times 11. I'm finding the three numbers we have here. That's the LCM of 5 and 11 times 25. 5 times 5 times 11. That's 275. I've just here. 275. 275 divided by 5. That's 55. Times the 3 you have here. 55 times 3. 165 plus 275 divided by 275. 1 times 1 and 1. So that's 1 square plus 1 is 166 over 275. And then that's the answer to that question. We've simplified it. Which is I have another question here. Cube root of 64 r raised to the power minus 6 r raised to the power 1 over 10. We have to be careful while solving this question. Now let's try to convert the cube root to an index first with an index. So what we have is 64 r raised to the power minus 6 r raised to the power 1 over 2, and then r raised to the power 1 over 3. So the cube root becomes what? 1 over 3. What's it? So we said the root becomes a fractional power, and then that would be at the denominator. If it's square root, it becomes 1 over 2. If it's fourth root, it becomes 1 over 4. Now its cube root becomes 1 over 3. Now we have 64 r raised to the power minus 6. Let's apply that law where we would have to multiply the two powers together. We have 2 raised to the power 2 raised to the power 3. What do we do? 2 times 3 becomes 2 raised to the power 6. We apply it here also. 1 over 2 times 1 over 3. That's 1 over 6. Over 6. And also here to apply the other law that says if we have a times b r raised to the power n, it becomes a raised to the power n times b raised to the power n. So we apply this here. What do we have? We have 64 raised to the power 1 over 6 times r raised to the power minus 6 raised to the power 1 over 6. 64 separately, we give it the power 1 over 6. Then r raised to the power minus 6 separately also give it that power 1 over 6. But the raised to the power 1 over 6 means the 6th root of 64. The 6th root of 64. And that's the number we multiply by itself. 6 times 3 is 64. And that's 2. 2 times 2 times 2 times 2 times 2 times 2 is 64. So that's 2. And then as for that's 2. As for r raised to the power minus 6 times 1 over 6, we're applying the same law to it. We come to r raised to the power minus 6 times 1 over 6. And you simplify that 6 times 1 over 6. 6 and 6 to 1, they cancel out. We have 1 left. R raised to the power minus 1. So 2 times r raised to the power minus 1. I simplify further by saying 2 times. Remove negative sign from the r, we have 1 over r. Then 2 times 1, 2 over r. Yeah. Here's another question. You have to simplify. A square b is by minus 3 c1 r is power 3 over 4. Then over a is by minus 1, b is to the power 4, c is power 5. Now you notice 1, 2, and you notice that there is a, b, c on the numerator and also at the denominator side. That means we have similar bases. But then let's try to simplify the powers of those numbers. Now as you can see, a, b, and c are in a bracket and they roll out 3 over 4 as the power. So we can actually split each of those letters and then give each of them power 3 over 4 by saying a squared is to the power 3 over 4 times b is to the power minus 3. You will know they have powers before. Here has the power of 2 before. Because you give it 3 over 4 that's outside. B has the power of minus 3 before because you give it the power of 3 over 4. Similarly, C has the power of 1 before, but you give it the power of 3 over 4 outside. Then all over A is equal to minus 1, B is the power of 4, C is the power of 5. And this is now equal to A is the power. Can simplify 2 in 4 is 2. Thus we have 3 over 2 times, as for B is the power minus 3 times minus 3 over 4. And 3 times 3 is minus 9. We have minus 9 over 4 then times c is power 3 over 4, then over a is power minus 1 times b is power 4 times c is power 5. We can see a is dividing a, b is dividing b, c is dividing c. We can apply the formula of indices that anytime you have to divide two numbers or letters and then you have the indices, you can easily subtract the indices. We subtract, say, a is to the power 3 over 2 minus, I subtract say. But then the power there is minus 1 also. Take note of that. Then times b is to the power minus 9 over 4 minus 4 times c is to the power 3 over 4 minus 5. Can say as for a, 3 over 2 minus the a, but at the bottom has minus 1, subtract, times b is by minus 9 over 4. The b at the bottom has the power of 4 minus 4 times c is power 3 over 4. The b at the bottom, the c at the bottom has the power of 5. So now simplify a is power 3 over 2. Next time minus becomes plus 3 over 2 plus 1. 3 over 2 plus 1 times b with power minus 9 over 4 minus 4 times 6 power 3 over 4 minus 5. So a is power, SM is 2. 3 divided by 2 is 1 times 3 is 3 plus 3 divided by 1, 2 times 1. 3 divided by 1, 2 times 1, 2 times SM here is also 4. SM of 4 and 1 is 4. 4 divided by 4 times minus 9, 4 divided by 4. 4 divided by 1, 4, and minus 4, we have minus 16. And the LCM here is 4. LCM of 4 and 1 is 4. 4 divided by 4, 1 times 3, 3, minus 4 divided by 1, 4 times minus 5, minus 20. Then now we have a is power simplified, 3 plus 3 is 5, 5 over 2. B is to power minus 9 minus 16 is minus 25 over 4. Then c is to power 3 minus 20 is minus 17 over 4. And that's the answer.